Hi everyone, this is Hasham and Ritwik from John Snow Labs, and today we'll be going over transforming HCC coding with healthcare specific language models. I'm Hasham. I'm a principal ML engineer at John Snow Labs. I work on training Gen AI models, NLP models, coming up with new experiments, brand new architectures, and benchmarking them, etc., and then putting them into production. I'll hand it over to Ritwik, who can go ahead from here.
Yep. Thank you, Hasham. So, hi everyone. I'm Ritvik. I serve as the director of healthcare payers and life sciences here at Johnson Labs. I mainly work around product adoption here at Johnson Labs and helping our customers align their data plus AI strategy in the insurance and life sciences space. Okay, next slide, please. Okay, so for this talk, we have a short agenda prepared. We'll go over a quick introduction of John Snow Labs. Then I'll be introducing HCC coding to you guys, explaining a little bit more about what HCC coding is about, who actually needs it and why, current challenges in HCC coding. Then Sham will take us over a technical overview of the HCC AI-enabled HCC engine that we have built here at John Snow Lab, a solution architecture, and an interactive interface as well, while we'll be ending with a public case study. Okay, next slide. Okay, so let's get started with who we are first. So John Snow Labs has been around since 2015. We are very well known in the AI and NLP industries due to mainly our Spark NLP libraries. We are the team behind Spark NLP. We created the libraries, we have grown it. We still have a team that is designated towards the development of Spark NLP that does a new release every 2 weeks. And what's really neat to date is the library currently has over 140 million plus downloads. Right now, John Snow Labs has 59% of the market share in the healthcare NLP space. We serve the majority of the world's largest pharmaceutical companies, most of the large medical academic centers in the US, large health systems. I think close to 15 of the top 20 payers are currently our customers who basically build solutions on top of our NLP models, ranging from clinical decision support to HCC coding, risk adjustment, prior authorization, and much more. Okay, next slide, please. Okay, and we have received various different awards, close to 50 plus at technical conferences for mainly our technical contributions, open source projects, and most importantly from our customers who have been successful using our models. We have over 100 plus public case studies that's directly on our websites. Currently, we serve over 500 plus enterprise level customers here at John Snow Labs. Okay, so I'll give you guys a quick overview of the technologies that we work on and what our tech stacks looks like on what we offer to our customers. So initially, after Spark NLP, we started with healthcare NLP libraries, and these libraries had over right now currently has over 2,500 plus pre-trained pipelines and models that are all trained on healthcare biomedical data sets. This is currently our marquee offering. We have navigated to creating medical LLMs now, state-of-the-art medical LLMs that are all trained on healthcare specific data sets. And these LLMs, we do a ton of benchmarking of these LLMs against GPT-4 on medical clinical tasks. And our promise to our customers is still that we keep them state-of-the-art with regards to any clinical accuracy in the NLP and LLM space. Okay. Okay, so some of the key capabilities of these offerings at John Snow Labs that we have is we are able to identify 400 plus medical entity types right out of the box using our NLP models, some LLMs, of course, now as well. And this is one of the key components for the HCC coding. First, of course, we have to recognize these entities, which we will get into it in a little deeper level in a bit. Next slide, please, Hasham. Then we also have quite a bit of pre-trained pipelines that can resolve entities to terminology codes like CPT codes, ICD-10, UMLS, MESH, RX norm. So we have end-to-end pipelines that you can simply just plug it in completely within your environment, and process your data, which will give you the structured output, codes as a structured output. So yeah, so what is HCC coding? So HCC stands for hierarchical condition category. This goes hand in hand with risk adjustment, which is a payment model mandated by CMS in 1997 and was actually implemented in 2003. Uh, this model identifies individuals with serious and chronic illnesses and assigns a risk factor score based upon their health conditions and demographic details. Um, the individual's health conditions are identified using ICD-10 diagnosis codes, which we quickly went over on a previous slide, that are then mapped to HCCs. CMS uses HCCs to basically reimburse Medicare, Medicaid Advantage plans, uh, based on the health of their members. Providers must report on each of these patient risk adjustment diagnoses and must be based on their clinical medical record documentation from a face-to-face encounter. Okay, so now jumping into who actually needs HCC coding, it's often said in healthcare that all roads lead to risk adjustment. Uh, and in healthcare, of course, HCC coding is extremely important because it ties directly to reimbursements for these Medicare, Medicaid Advantage plans. And HCC coding is essential for a wide range of stakeholders in the entire healthcare ecosystem. Providers such as hospitals, physician groups rely on HCC coding to ensure proper reimbursement, of course, and optimize revenue under value-based care models. It helps them capture the full complexity of the conditions of their patients. On the other hand, of course, payers, including MA plans, submit these codes to CMS for their reimbursements. And then, of course, there's a bunch of outsourcing vendors that help both payers and providers do HCC coding completely offshore end to end. So they also need to do HCC coding. And of course, CMS uses these for their reimbursements to payers and payviders both. Okay, next slide. Okay, so going over the current challenges of HCC coding on the slide. So typically what we have seen that organizations are spending a lot of time and resources on risk adjustments since the process is very um, laborious and error prone, since it has always been a very manual chart review, which was very inefficient and expensive. And of course, as everyone knows, there has always been a very significant shortage of medical coders in the U.S. healthcare space. And they're always spread very thin with all the documentations that they have to review, all the education that they have to give to providers so that they're documenting these HCC codes correctly, which of course follows the value chain. And what we have typically also seen that payers rely heavily on outsourcing chart reviews for HCC coding. One of the significant challenges with this is sharing PHI, PII outside of their environment while outsourcing. To, like, let's say even technology vendors, or just simply just outsourcing it to a vendor that's getting the stuff done manually in an offshore country. So even with technology vendors, they have to call an API which does the processing of these patient charts externally, which we have seen is usually a pretty big challenge because the data is being sent outside of their environment. And in most of these cases, payers have to get pretty significant agreements in place and have to worry about data leakages uh, while sending data outside of their environment. And another critical challenge in HCC coding is, of course, inaccurate coding by providers, which often leads to payment delays and additional audits. And it can result in, of course, lost revenues, uh, undercoding and overcoding, which can, of course, result in a higher number of rejections or even audits. So these are a couple of significant challenges that we have noticed with HCC coding. Okay, next slide, please. Okay, so I wanted to quickly go over an HCC coding workflow for payers that we have developed. So health plan, or like, let's say the vendor requests medical records from providers for the health plan to review. Then Johnson Labs HCC engine reviews the medical record to abstract supported conditions, ICD-10 CM codes. Then medical coding QA staff reviews the abstracted HCC relevant ICD-10 CM codes, either highlighted on the patient charts itself or right beside it. Depends on what kind of workflow that they would like. We'll quickly go into a short demo. And then, of course, the health plan submits the abstracted and the validated diagnosis codes to CMS, and then CMS uses those for reimbursements. And there's an audit trail during the entire process. Okay, Hisham, over to you.
Okay, thank you, Ritvik. So let's go with the technicalities and a bit more details about the solution. Essentially, when we started with this, it was essentially a simple NER model, which is not the case anymore because simple NER model does not, uh, it cannot cater to the nuances for HCC, which includes dealing with the historic conditions, differential diagnoses, etc. So what we have done, what the final solution is, what we've built is we have those base NER models that are running underneath, but then we have a light reasoning layer on top that are based on LLMs, and we're moving towards SLMs now. But the basic idea is to first extract codes, first extract terminologies and concepts, really concepts, conditions, diagnoses from text, and then we apply a reasoning layer on top, which takes care of assigning contextual assertion status to it. For example, if it is historic, if it is something not related to the patient, etc. And then we also exclude things like again differential diagnoses or anything that is not 100% explicitly confirmed by the provider. So this is the main part of the reasoning layer, and this is where it actually helps improve the results, because we only let those concepts go through that have been explicitly confirmed or stated by the doctor or the provider. Um, in short, there has to be enough evidence for substantiating, and the reason for that is we tune this solution for both precision and recall. If we increase the recall, we get too many false positives, so the false positives are actually catered by the reasoning layer. So yeah, and this helps during the audit process as well, because we can literally apply the same pipeline to see, given a code, if there's enough evidence in the text as well. So that's the first layer actually. So we extract the chunks or the concepts and diagnoses from the text. Then we map them to ICD-10 codes. That is done via kind of like a vector search. We embed them in embedding space. Then we find the closest one, and then we pull that code, and then we map that code to HCC category, which is a one-to-one mapping, and we end up with conditions, their related ICD-10 codes, and their HCC categories. And if we are able to, so this is the main HCC workflow. Then if we are deploying this either at a provider's office or at a practice or for a payer, and we have information, additional information available, which is demographic, plan details, eligibility information, enrollment date, etc. If we get that information as well, then we pass all of this to a RAF score, and we get the final RAF score for a given patient. So this is the complete workflow, including RAF. Let me quickly show you the default interface, how it actually looks like. So for example, given a document, a note, a medical note, one point worth mentioning over here is it could be any type of medical note. It could even be flow sheets for that matter. It could be any type of document. And you can just pass it to the solution, and it would try to, it would work with it. It would try to find HCC codes and HCC conditions. Again, all inside your environment. Nothing gets sent out anywhere. It uses local resources. So as you can see here, that given this node, this is where the provider, the doctor, actually confirms um, three conditions: heart failure, diabetes, and COPD. And we extract that and then we map it. So and according, based on, if you look at the UI, we can, a coder can actually just go in there, look at the results. For example, they look at this and they're like, oh, this is confirmed. I mean, they find it to be okay. They just click approve and it's confirmed. For this one as well, they say, okay, approved. It's confirmed now. If, let's say, they want to make a change to it, they just go edit and then they say decline or not billable. Let's say they say decline, then this will be removed, right? And then they can go to another one, then they can say approve, and then they just update and then submit. And that's essentially it. And then their version would actually be saved over here. So this is how it all ties together in a UI, where coders can just go in, look at the predictions by the model, and just either confirm or decline any of the codes. So it is giving power to the medical coders as well. The best part is that it would automate a lot of the workflows, and all the users have to do is just confirm or just validate if the code is correct or not. So they don't have to go through hundreds of pages to actually look for the codes. Everything would be done by the model. So this is what the interface is. And if you notice that in that interface, we do not focus too much on RAF. The RAF is actually focused on when we integrate it with either EHR or Pairs database. But the benefit of RAF over here is that the tasks that the reviewer or the coder sees, those tasks are actually sorted by the RAF score of a patient. And we can even calculate the RAF score before and after running the model. So for example, we just take historic data of a patient, all the things that have already been coded, and we just calculate a RAF score. Then we run the pipeline, the NLP pipeline, the engine on it, and then we again calculate the RAF score and see if there's any change based on any new findings. And the benefit of this is you are able to identify things that have been missed, codes that have been missed, and get a more accurate representation of the underlying conditions or the risk factor of a patient. And here is what it looks like as well. So the RAF engine, as I explained, it would just take information from EHR, etc., and it would display results in a tabular form just like this. So you would get your codes, the score for each of the codes, their HCC categories, and then your total RAF score, and then adjustments based on age and plans, etc., etc. So yeah, that's essentially it. As I explained, so integration with EHR providers, if we can get, mostly this is the case when we deploy it in at practices, we would just integrate it with Epic. If we deploy it at a Pairs environment, we would integrate with their other systems. But the main point is that because it's a standalone system, it can be integrated with literally any type of EHR, any brand, any type of database. There's just a staging layer. So essentially what we do most of the time is we have a staging layer that just pulls data from the EHR and stores the result in a staging environment. And the model pulls the solution, or the HCC engine pulls data from that staging environment and then processes it and then dumps it back again. That way you have complete control over the data flow as well. And again, it's all private. There's no external API call. And one important thing over here is that it is flexible for real time and batch. If you want, usually we see that it has more of a use for batch processing because it's faster and you can run it on historic data as well. For example, if we talk about a use case, we did West Virginia is one of our main customers that have been using this for more than a year now. They have 100,000 patients in total in their health system, and we started initially with we integrated this with Epic, and the way this works is we run ETL jobs every single day, and we get the records of the patient that are scheduled for the next day. So we pull all their historic data. We run the HCC engine on top of it, and we get the new codes. We get the difference, what was already coded and what hasn't been coded. So we get the new codes. And when the appointment actually happens and the patient is in the office, then the providers are then suggested these codes. So there's a pop-up that says, oh, here's a code that was missed that hasn't been coded, let's say 2 months ago. So, or do you want to code it? And then it suggests it tells you the chart as it tells you the evidence inside that chart, as I showed you earlier. So the provider can then just quickly look at the chart, look at the evidence, and then decide, oh, this really needs to be coded or not. Yeah. So this is what has been done with WVU. So we started with every day we process around 30,000 documents every single day. The job runs during the night. And yeah, by the morning, the results are ready for the providers to review. And this way, it actually increases, reduces any leakage in patient care. So what are the key takeaways? AI-assisted HCC can actually help scale HCC coding operations. You don't have to actually outsource a lot of the solutions. You can you literally have the solution in house, so you can scale it much better. In terms of patients, the impact it has on patient and their care. Obviously, once you're able to accurately profile a patient, calculate the right draft score, calculate the right conditions, find the right conditions, and map it to the right ICD-10 codes and HCC codes, then obviously you are able to get more. You're able to actually provide better care to the patient. It reduces any revenue leakage. It improves patient care. And it also it can lead to less audits as well, because as I suggested, that the solution is tuned to reduce false positives. So you can actually, you're very confident that whatever is suggested has substantial evidence in the text. And another thing is that we can literally take the same pipeline and just apply it in reverse. Usually, let's say if CMS wants to deploy it, then they would just apply it in reverse and get the same, like use it for audit purposes, because the reverse of this pipeline would be starting from codes and then finding evidence in the text. Right now, we're taking the text and finding codes. So the reverse would actually be for audit purposes. So it's more expandable in that manner. Yeah. So that's essentially it. Thanks for joining in and listening to us.